So let's say I have a cylinder. Let's say I have a cylinder. The radius at the base of a cylinder is 100 inches and this cylinder is 300 inches tall. Now, however, this cylinder is changing in shape for each second. The radius is going to be increasing by 2 inches per minute. So the cylinder is actually getting bigger, but the height is decreasing by 3 inches per minute. So my cylinder is getting wider but shorter. So you can think of it that way. I like to find the rate of change of the volume of the cylinder after 10 minutes. So you can kind of imagine, if my cylinder keeps changing its shape, then its volume is going to be changing over time. So I need to find out how fast the volume is changing after the transformation is going on for 10 minutes. So let me recall a few formula. The volume of a cylinder is gonna be pi r squared h. So pi r squared is just the area of the base or the top, and h is the height. So I need to find the rate of change of the volume in 10 minutes. So I need to find the derivative of v with respect to time. So, but I don't. How do I find that? I knew that I have this guy. So in mathematical terms, this is what I'm looking at. I have my volume is pi r squared h. I knew. Okay, let me. I knew how fast r and h change over time. I knew how fast r and h changes over time because, well, my r is increasing by 2, my h is increasing by 3 for each minute. And then I need to find how fast v change over time. So it seems like I can somehow take, I knew how fast r change over time, I knew how fast h change over time. So maybe if I can somehow take the derivative of this guy with respect to t, then I would be able to find dv by dt because I know dr by dt and dh by dt. And that's exactly what I'm gonna do. So my dv by dt, I'm just gonna take derivative of this whole chunk. I have two things multiply, so I'm gonna use product rule. So it's gonna be pi r squared times dh by dt plus derivative of pi r squared is gonna be pi derivative of r squared is going to be 2r dr by dt times h. Now, so it seems almost good because I know dh by dt. dh by dt is going to be my negative 3 because I know the height is going down by 3 inches per second. And I also know dr by dt because I know my radius is getting bigger by 2 inches by second, I mean per minute. Now, so I could almost find this thing. I'm only left with finding the r and the h. The r and the h. Now, well, I also have another number that I can plug in. I have 100 here, and I have 300 here. So it seems almost as if I can use this number for r and for h. However, that would not be correct because I need to find the r and the h at the 10 minutes. So the r and the h that I have, this is the r and the initial r and h. So this is the r and h at the start. But I need to use the r and h in 10 minutes to find the rate of change in 10 minutes. So let's see what's going to happen to my cylinder in 10 minutes. So if my radius keep going up by 2 for 10 minutes, that means my new cylinder is going to be 120 in radius. And my height, because it's going down by 3 per minute, so it's going to be, it goes on for 10 minutes, so that's going to be 270 in height after 10 minutes. So my picture is not exactly up to scale, it doesn't change actually that much. But anywho, that's going to be the r and the h that you are going to use. I plug the whole bunch in, so that's going to be pi times 120 squared times negative 3 plus pi times 2 times 120. Wait, I mean 2r, so that's going to be 240 times 2 times h, which is 270. I kind of cheated because I have computed all this at home. So this is going to be negative 33,200 pi plus let me see 129,600 pi. So that's going to be, let me see, 86,400 pi. The unit is going to be inches cubed per minute. So that means at 10 minutes, the volume of this guy is changing by this much cubic inches per minute. So that means in 10 minutes, it's actually still going to get bigger.